Hi, welcome back to my channel. If you are new here, please consider subscribing. In this video, I'm going to show you how we can simplify these expressions once given some other terms that are in form of trigonometric functions. So you can pause this video and look at the problems, and then let's get started. Question 5a is saying that if x is equal to a sine of theta, then we do simplify, and what we are simplifying in part A is a squared minus x squared. So simplify that. So again, the idea, just plug in x, that means we have a squared minus a sine of theta, and this is squared. And so we have a open up, so this is a squared and this is sine squared of theta, and I can say common factor a squared into 1 minus sine squared of theta. Now in the previous videos, recall or in the previous questions, recall that we used the identity of cos squared plus sine squared being equal to 1, so which means this upper part, this part in the brackets can reduce to just cos squared of theta, and so we have a squared into cos squared of theta. How? Just recall that sine squared theta plus cos squared theta is equal to 1, so we are substituting for this part from this. So let's look at part B. Part B says 1 over, simplify 1 over a squared minus x squared. So we can just borrow the upper part, which we have already reduced to this format because it's what we have inside, to avoid wasting a lot of time. And so this becomes 1 over, but in the normal situation you have to substitute in and do the simplification. So this is a squared minus a sine of theta squared, and so that means we have 1 over square root of a squared minus a squared sine squared of theta. And so do the factorization of the a squared. So we have square root of a into 1 minus sine squared of theta, and so again this means we have 1 over this is squared, so 1 over a squared, and this inside part is the cosine, cosine squared theta. And so you can see the square can cancel with the square root on both of them, because technically this is the same as 1 over square root of a cos of theta, the whole thing squared, so the square can go with that, leaving us with 1 over a cos of theta. So instead of leaving it like this, we can just leave it as 1 over a times sec of theta as that. So we can therefore say that 1 over square root of a squared minus x squared is the same as 1 over a sec theta. This is a very important substitution when it comes to integration. So let's look at part C of number 5, which says that we simplify a squared minus x squared everything over x. So I'm just going to borrow the answer for this, which is this right here, and then plug it here, which says so. But in the normal situation, please just substitute in and continue simplifying. So this is going to give me just a squared cos squared of theta everything over x, which is the a sine of theta. So let's continue. We can cancel that, and so we have a times, we can split this up in terms of cos of theta over sine of theta times cos, because the upper part is squared, the one of cos, so this is cot, and so we can see that this reduces to a cot of theta times cos of theta. So therefore we can say that a squared minus x squared over x is equal to a cot theta cos of theta. And so that is how we can reduce that. Then let's try to look at number 6. Number 6 involves substitution of y is equal to b cot of theta. Then we simplify. So the first part is very easy. Part A is very easy. It's asking you to simplify b squared plus 1, which we can quickly go ahead and do the substitution for y, which is b squared plus y, which is b cot or theta, the whole thing squared. And so we can see that this is b squared plus b squared cot squared of theta. And so we can factorize out of b plus 1 plus then cot squared of theta. So, but recall this can be substituted for with cosec. So that means I can say that b squared plus y squared is the same as b squared. Then this inside part is the cosec squared of theta. So I'm just borrowing this from a trigonometric identity, which you can derive. We have seen this many times. First, trigonometric identity, if you divide it out by sine throughout, that will give you 1 plus cot squared equals cosec. So let's look at part B. Part B is if you have y, then square root of b squared plus y squared. So simplify that, and so just go ahead and substitute in. So wherever there's y, do the substitution. So this is b cot square root. Again, I'm going to make a use of the inside part, which you have already simplified here. But in the normal case, unless these questions are related to each other, in the normal case you need to substitute in afresh and continue getting this answer. So but in this case, this is the kind of related, so I'm just borrowing the final simplified expression from here. So that means inside part is b squared squared of theta. And so when we do that, I can just express this in terms of cos and sine, so which is the cos of theta over sine of theta times the inside part. You can also observe that the squares are going to go with the square root, so that means we have b cosec of theta. But again, what is cosec? We know that cosec is 1 over sine, so that means we have our b squared here multiplying, and then we have our cos of theta over sine of theta times cosec, which is 1 over sine of theta. And so these two can multiply, and thereby giving us b squared cos of theta everything over sine squared of theta. But what is sine squared theta? That can be taken to the cosec. And so the simplified answer for this would be left in this form, being equal to b squared cos of theta times the cosec squared of theta. So that would be the final simplified answer for this expression. It cannot reduce any further from. So we can just keep it that way. So that is part B. Let's look at part C. So in part C, we are given that y over b squared plus y squared. To simplify that, again just do your substitution for the y, which is the b cot of theta, and then you have b squared plus the y squared, which is the b squared cot squared of theta, then which means that we have our b cot of theta. Then the b squared can be factorized out into 1 plus the cot squared of theta. And again, just recall what is cot. We know that 1 plus cot squared theta is equal to the cosec squared of theta. So which means I can first reduce the b's here, and then I have the cot of theta over b into O times cosec squared of theta. So let's express everything in terms of sine and cos. So we have 1 over b times cot is the same as cos over theta of theta over sine of theta times 1 over cosec squared, which basically goes to sine squared of theta. So observe that we have sine down here, which can reduce with sine there, and so we can see that this goes to 1 over b cos or theta times 1 sine goes with this, and so what survives is just sine of theta, and so we can have that therefore y over b squared plus y squared is the same as 1 over b cos of theta times sine of theta. And so that is our simplified expression when you have y is b cot of theta, and then you have this expression. So let's try to move on the last question, which is question 7. And question 7, you are given that z is equal to a sec of theta. So then part A wants you to simplify z squared minus a squared. As usual, just do the same thing, plug in whatever you can plug in as given, and then try to simplify stuff. So this means we'll have a sec of theta squared minus a squared, and so we can open up. This is a squared sec squared of theta minus 1 minus a squared. Observe there's a common factor, a squared, so plug that out. A squared, which gives you sec squared of theta minus 1. Now again, borrow the identity. We know that 1 plus tan squared of theta is equal to sec squared of theta. From the first identity, sine squared plus cosine squared equals 1. If you divide throughout by cos squared theta, that gives you this identity. So that means I can take 1 this side, and then I have that tan squared of theta is equal to sec squared of theta minus 1. So this is equivalent to that. So I can go back up and say that means I have a squared times the bracket, which is equal to now tan squared of theta, which can be reduced just to a tan of theta, then everything squared. And so then I can say this implies that z squared minus a squared is